Hey everybody, and thanks for joining us for another one of our webinars. We are really excited to be joined by the team from Mongoose IM, who will be talking to you about the best practices for building a chat app that not only delivers on its promise, but also adds value to a product. If you're not familiar with Mongoose IM, they have over a decade's experience building highly scalable, customizable instant messaging solutions, and they've built a few of the world's most in-use chat applications. And so this is what they do. And at a time like now where connection is so valuable to all of us, I think it's a really good time to look at what makes not just a good chat app, but an app that adds value. Without any further ado, I will like to introduce you to Bartek, who is going to be taking the first half of this presentation.
Hello, everybody. My name is Bartek Górny. I'm a Erlang engineer, developer, consultant, and a trainer, and I worked for Erlang Solutions for a couple of years, mostly on Mongoose IM. First of all, if you hear any extra voices or noises here, please excuse. We have a lockdown here as well, and we cannot always control our environment. Nowadays, it's the government that controls everything. So, without any further ado, let's move it. We are going to talk about chat application. Do we need it? Why we need it? From my perspective, first of all, the world is moving faster and faster, and the people spend less and less time, for example, on choosing stuff that they are going to use. So when somebody looks for a service, the standard practice is opening 20 tabs in a browser and closing them one by one, unless some of them makes them stop. So, and the chat window where you can issue a fast query gives slightly increases chances that the guy is going to stop here and make an inquiry. Email has been around for decades, and it's still used by, as probably everybody noticed, it's more and more for official communication where you need a record and it's slow. Email is now a slow medium. But it's more and more instant messaging. And especially today, when we have a almost worldwide lockdown, it becomes even more important to communicate with someone knowing and feeling the guy's or the girl's presence and at the other end of the wire. So it sort of adds a human touch to whatever we use. Well, since you are here listening to me, you probably know, you have your own reasons why you are interested in adding a chat feature to an application you are working on or about to work on. Maybe one of these, maybe you have your own. We will have a while to discuss after the presentation, so you may speak up then. So, if we want it, how shall we go about it? First of all, the chat application is much more complicated than many people think, because these things are usually made very complicated under the hood, and most of the complications go into making them appear simple. For example, if you use a chat application, a messenger or application like WhatsApp or whatever else, well, you send one-to-one message. Can it get any simpler than that? You just type something, click send. After a while, you see a green check mark, and this is it. But what's going on under the hood? A lot more. This, what you see on the screen, is a simplified diagram showing what's going on in the trivial case of sending one-to-one message from one smartphone to another. So the guy on the left, the smartphone on the left, sends a message. And first of all, his own server sends back something. We call it a chat marker. It can be under many names. An information that, okay, your message has been sent. Sent meaning that it's been processed by the server. It goes into sender's archive. It updates sender's inbox. Inbox is a way of tracking unread messages and the last message that's been sent, been exchanged. Then it goes to another server, the recipient's one. It goes to archive. It updates inbox. It's being delivered. So now we have another backwards message saying, okay, the message went through. Just to show you another check mark. And then there's either a push notification or the message is delivered straight. And then once it's displayed on the recipient's phone, then there goes another backwards message saying the message has been read or displayed or received. So you just tapped once to send your message, but here you have how many? 8 operations going on. This is much more complicated than it seems. We had a client once who wanted us to build a server for a clone of WhatsApp. The rationale behind it was not to kill WhatsApp. They wanted one-to-one copy, but it was strategic sector in a certain country. So they wanted to use WhatsApp, but they couldn't because the communication was not allowed to go across the border of the country. So the task was pretty simple: build a WhatsApp clone. And it was a lot of work just to figure out how WhatsApp works, what it really does, just to show you, okay, you are chatting with someone about whatever your interest is. So, and this was only one-to-one messaging. Now, when you go into chat groups, it's much more complex, because the chat group is multi-user chat, is basically a way to distribute messages to a number of people. So delivering messages is pretty straightforward. I send a message, there is 20 people in chat group, the message goes to the 20 people, done. But then comes lots of questions, how the chat group should work under the hood. For example, it should archive messages. Great, but should it be one archive for the whole group? Or should it be 20 archives, one for each of the group members? Should it go to private archive? This is a non-trivial question. It affects storage, it affects CPU load, it affects traffic, and it affects logic. Because what happens if I send a message to a chat group and I want to delete the message? Do I delete it for myself, or should it be removed from for everybody else, or should it still there? Then, in the previous picture, we saw that usually a message status is tracked. Was it delivered? Was it read? Great, but what does it mean that the message was read by a group? Does it mean that it was read by everybody, or by, I don't know, majority of people? It's a non-trivial question. If we have a chat group of 5 people, then we can safely track the message read status for everybody, because we can collect 5 chat markers and say, okay, everybody read the message, there goes a green check mark. But if a group has like 500 people, do we seriously want to receive 500 chat markers? And if there are many people, then there's no way that everybody's going to read it. We probably never. We'll go through lots of work, lots of network traffic, just to not display the green check marker at all. So maybe there goes another question. Maybe you should track message read status for small groups and not for large groups. But what's small group and what's large group? And so on and so on. So I'm talking about this to show you how a simple, apparently seemingly simple feature, when you start really thinking about how to do this, it sort of balloons into something really complicated. And it's still simple general purpose chat application. What about custom implementation? This is our daily bread in Erlang Solutions. Custom implementation differs from general purpose chat in that it is attached to some other functionality, some other service, which does something, and we want to enable instant communication in relation to this something that the application is doing. It can be dating application, it can be job search, it can be auction like eBay, Allegro, or whatever there is. So the message is not just a message, it is related to something. Like, for example, an auction. Let's stick to this example. It makes message distribution more involved because if we have a seller and a couple of bidders, then a bidder probably will want to message the seller, just for example, to know more about the product. Then the seller can message the bidder or can message all the bidders, for example, some new information. And then we probably will have some auto-generated messages that I'm a bidder and I receive messages about competing bids, that I've been outbid, for example. So there's a lot of intricate logic here. And the point is that it should work in a way that is obvious for the end user. So there's also always a lot of design thinking which goes into this. If I, as a user, see a chat window that I can type something and send, I should immediately, without even thinking about it, know where this message is going to go, and I should be right. Because otherwise there will be hell of a confusion. And another aspect, it has to work smoothly with all the rest of the application that we are attaching our chat feature to. Because if you have like dating or job search, you probably have a user base. You have these entities like auctions, like job offers. You have some archive. Message archive has to probably, in most cases, has to work for both parts of the system. So there's another level, which is integration. And it's again non-trivial task to get it right. So the structure of our presentation is this. We'll talk about how to approach the task of adding a chat feature to an application. Then we'll talk about how to choose technology. We'll try to give you some guidance how you should proceed and what should you pay attention to when thinking about what to use for this. Then there are two more stages. Which once you know what to do, once you know how to do this, once you've chosen technology, then you have to build and run it. So we are not going to talk about the last two parts because they are a straight consequence of the previous choice. So there's no use of talking about them. But we'll concentrate on these three items. So we'll sort of proceed from generic to specific because I must admit, we are somewhat partial because we've spent years working with Mongoose IM and with XMPP chat protocol. So this is what you know best, and that's what we believe is the best. Because if we didn't, we would be doing something else. But you don't have to. I mean, your mileage may vary. So we'll give you some insight into how it works and what are the possible options. So then you can explore. If you choose Mongoose IM and XMPP, we're happy. If you choose something else because we've given you good advice, we are happy as well. So first stage, think what you want to do, because we already know why. So now we are talking about the what. Well, you want to add value for the user. We are not going to talk about marketing because we don't know the first thing about it. We are not going to talk about the UX because we are server-side developers, consultants, engineers, and everything else. This is really be to people who know more about it. We know how to figure out how it should work. What features does it have to provide? It sounds pretty obvious, but I'll tell you something. I once spent 3 very interesting weeks in Bangalore in India, and most of it went into working with the client to figure out what the chat part is really supposed to do and how does it fit into the rest of the application. Because they had a good idea, but it needed a real insight for them and for us together to realize how much we still have to design. And this is what we did. So we have to design the specific features, the data structure, because again, this was chat that was related to some other entity that was created in the application, how the information is going to flow in every direction, and how it's going to interact with other components that were already developed by them. So we think what? Now, then we need to think how. And the first question is choice of a protocol. There is XMPP, of course. There are other chat-specific protocols, like the ones that are used by Signal, by Telegram. There are proprietary protocols. There are open source protocols. There's a wide choice. The main choice that has to be made first is: are you going to use a dedicated messaging protocol, or are you going to work on some basic transport protocol and implement your chat logic on top of it? What I mean by this, there are protocols that are used for exchanging messages, like MQTT or AMQP or STOMP. There's quite a few of them. And then what you can do is use one of them as a transport and use it to ship your JSON, for example, data structures, and then implement your logic in this way. So this is sort of the left diagram shows how it's a block diagram of this approach. And another approach is take some base protocol that is extensible and build your logic on top of this protocol, but using the same paradigm, the same logic. And this is how XMPP works. We will we'll talk about them in more detail later. And of course, it has its advantages and its drawbacks. The drawback is, of course, that you have to follow the base protocol approach. You have to really learn the ropes and follow the same way of doing stuff if you want to build your extensions on top of the base protocol or on top of existing extensions to the base protocol. The advantage is that you have a consistency. You have only one protocol to deal with, and from top to bottom, it works exactly the same, whether it's the core of the protocol or your custom extension. So your mileage may vary. You may like it, you may not. Now, if you went through this, then you're facing a choice of technology. So again, there are many approaches. You can just buy one and pay bills. You can build your own from scratch. You can use one which is already there. And if you are going to choose one that is already there, you have to make sure that it's sort of fills some major criteria. Like it needs some essential features just to make it usable for you. It's good if it's extensible, because chances are you are not going to just start some ready-made product and enjoy. But you are doing something more sophisticated or more fancy or more specialized, something that's is sort of, how is it called? Well, that adds something to the world, that has some selling point, for instance. And again, if it's not as just standalone server, which it never is from our experience, it needs a tool set or interfaces to integrate with other parts of the system. It needs to be fast and scalable, unless it's just for like one college for internal use. Then the scalability very quickly becomes a really important factor. And in the world of mobile devices, it needs push notifications. And it may be or may not be open source. We are very much in favor of open source solutions, but why it's actually out of topic. So we are not going to get deep into this. We can discuss it some other time. So what are the essential features that the chat server must have? It has to accept connections and allow establishing and managing user sessions. It needs authentication. It usually needs to be able to distribute presence information like online, offline, away, working, busy, sunbathing, whatever there is. You are online, basically you are available or not. There are some specialized applications where presence is not required, like a sales chatbot, it's always present. But in most cases it is. Then a roster, a way to manage your contacts. This is a very important thing, and it's like it is basic requirement. And now there is something that is not very basic requirement, but nowadays it's absolutely essential. And I will stop here for a while and talk in more detail about this one, because the rest is pretty obvious for probably most of you. What I mean by this, when you establish a session with a chat server, there is quite a few traffic involved. There's a few round trips are usually done, because you have to authenticate, you have to get your offline messages, you have to update your roster, you have to check what's new, and so on and so on. So there's quite a few operations that needs to be done every time you establish a session. So you establish a connection. But this involves some traffic and some work both on the client side and on the server side. So client loses battery power, server has a huge load spikes, and mobile devices have an annoying habit of disconnecting every 2 minutes. So if you have 200,000 online users using mobile phones, you can quickly calculate how much work the server has to do all the time just to let them reconnect. So stream resumption is a neat feature, which means basically that once you establish a session and you did all the initialization work, your session is stored on the server, and if you go offline, it waits for you. If you go online within a few minutes, or some other reasonably short time, it is just restored. So it's a huge resource saver. And it's not a core feature of chat protocol, but it's a very important thing to have. Now, there are many features that are very often used, but this depends on how your chat is going to be integrated. For example, in virtually all cases, you want to store your conversations somewhere, unless it's really ephemeral stuff. We are not talking about Snapchat. So you need an archive. But again, the archive can be stored in a chat server, or the chat server can push its messages somewhere else for storage. So you need either this or that. If you're going to integrate, you need a REST API. If you want your users to be able to share files, there are a couple of approaches here. One of the most common is using HTTP file uploads, because files are usually shared by storing them in a external storage and letting the other user download this file. These cryptic digits, these codes here, are extensions to XMPP protocol. More of the later. Another way to integrate is adding external components to your chat server, for which there is also a sub-protocol. There are things that are not strictly essential, but in most cases they are nice to have. Like inbox. Again, if you open a chat client, you usually see a list of your contacts and a marker saying you have 300 messages and the last message is about this or that. So this is what inbox does. So it sort of caches this information so that you don't have to download your archive and manually, so to speak, count the messages. There is privacy, which is about enabling you, making it possible to block some users which are you don't want to talk about, or blocking commands, which is a simplified version of privacy. There are vCards if you want to publish information about your full name, the department, your company you are working for, your picture. Then the vCards are for, it's sort of virtual business card. There is private storage, which lets you store your custom information on the server so that you can use it from multiple devices. So these are features that you may need, you may not. There are many, many more features that are possible and are implemented by many chat servers. I'm just skimming through the most popular of them because otherwise we won't finish by midnight. And now there are more specialized features that are used in more specific applications. Multi-user chat is quite generic. There are in XMPP there are two options. There's multi-user chat and multi-user chat lite, which is mostly used in mobile devices. There is publish subscribe. So multi-user chat is many-to-many communication. Publish subscribe is one-to-many. So it's a basic for many more advanced features like personal eventing and also encryption. If you want to use end-to-end encryption, you need publish subscribe to publish your encryption keys. And finally, there is something that is very specific and very sophisticated and very rarely used, which is advanced message processing. I actually so far met just one client which used this, but it was for sort of security critical application. And this was a very important part of it because it lets you, for example, mark your message as going to expire within a certain period, and then the message is deleted and you are notified, for example. So the advanced message processing is to make sure your contact, your peer, will not receive a message that is outdated. So as, for example, not to create confusion or to breach some security regulations. So this is really used, very advanced and for very specialized applications. Now then, as I said at the beginning, we are sort of funneling you from generic talk about what's chat applications all about into more specific and more sort of our approach to doing stuff. What we are dealing with, I mean, if we are asked how, we ask, okay, use XMPP, because XMPP stands for Extensible Messaging and Presence Protocol. And the point is that the extensibility is sort of built into the core of the protocol, and much of the real stuff that is in XMPP is made as an extensions. Let's see how it works. The very basic of XMPP is based on XML. It works by exchanging, we call it stanzas. Stanza is just a piece of XML that is either a presence or an IQ or a message. There are only three types of stanzas, and they all have very specialized, very well-defined meaning and purpose. A presence is for telling people about your presence. Are you online? Are you away? And this is it. This is all it does. And if you send a presence to your server, it's distributed to everybody you know, or everybody who is entitled to receive your presence information, because it may be something like personal. So this is one thing. The other is info query, or IQ for short. And IQ is designed and mostly used for communication between client and the server. So if you want to, for example, this IQ is sent by a client to get its roster. And the third kind of message of stanza is a message, and message is for communication between clients. So a message is something that I would send to you, send to you to tell you some, say hello for you, for example. If you are familiar with XML, you can notice that the IQ stanza contains a namespace entry. A namespace is sort of the most important part of XMPP design, because basically every tag or every word like presence, show, IQ, message, body, it needs to be defined somewhere. This is how XML works. And most of what you see here
Hey guys, I'm sorry. There has been some thunderstorms around Krakow where our presenters are, and I think at this stage both of them have lost internet connectivity. I know we lost Mikhail, who was due to be our second presenter about 10 minutes ago, and it appears that Bartek, who was in the middle of presenting, may have logged off. So please bear with me as I try to determine how they're going and how we can get them back. In the meantime, while I do that, it's probably worth letting you all know we've recently launched our online training offering. Involved in that is a bunch of different courses for all different levels in a lot of technologies, from beginning to expert. They're all run by senior members of the community, including Robert Verding, who is the co-creator of Erlang, and Francesco, who is the co-founder of Erlang Solutions, the company. And all of our courses are taught by industry experts who are currently working with some of the biggest names in the world. And so that means they're getting hands-on in production experience that they can then share with you. We keep the classes small so that they can remain interactive and you can get hands-on personalized feedback and treatment, and so that it still feels intimate and that you can get as much from the course as possible. In amongst the training courses we're offering, there is training courses to Mongoose IM. So if you're interested in that, I will post a link in the chat for everybody. And I'll also post a link to all of the trainings that we run so you can see them and hopefully find something that is for you. Bear with me, please, while I try and... Okay, perfect.
I think I'm back.
Perfect.
Yeah, I'm back. I don't know how many of my valuable speech was lost. Hopefully not much. Okay, so again, XMPP basic, that's where we were. We have an IQ query. In this case, it is set, which means we are trying to write something onto the server, because it's like bidirectional communication. And it shows that we have a query which is qualified by Jabber IQ roster namespace, which means we are trying to set a roster. And the Jabber IQ roster namespace defines stuff like query, which query can have many meanings, and this is the query defined by the roster namespace, item, and group. So that's the definition. That's what namespace is for. And the server can receive such an IQ and just reads what's inside. When it meets the namespace it is familiar with, it begins to process it according to the meaning of the element name. And to the right we have a message. Message normally contains a body, but it can contain many more stuff also. For example, here we have a message with a so-called chat state notification, which basically means that I'm typing. So my friends will see on their screens will say some message like Bartek is typing or something like that. And it's qualified by the namespace chat states because it's chat state notification. And now, about this message, it's client to client, and the other client has to understand what composing means. The server just doesn't care, because the server reads the content of the message. If it finds a namespace that it recognizes, it acts accordingly. Otherwise, it just ignores. And for example, this is a message which is meaningful for both the other client and the server, because this is chat marker for a change. And the bottom message basically means that I've read a message with ID 1, 2, 3, 4, 5, 6. So my friend's client application will like mark this message as read or displayed, and the server will recognize, if it implements inbox, it will recognize the chat markers namespace and will update my inbox, so that there are no more unread messages with this contact because I've read them. So it's all about extensions. There are 4 RFCs which are officially registered by Internet Engineering Task Force, and then define the core of the protocol, like establishing sessions, authentication, roster presence, stanza format, quite a few things. But most of interesting stuff goes into XEPs. And this is, now we have a flashback. Yeah, we've seen the XEP tag. Yes, it's XMPP extension proposal. An XMPP extension proposal defines pretty much everything you are going to use. They are about 150 of them. And most of them define some features, like message archive management, like inbox, like chat markers, like privacy, HTTP uploads, you name it. And but there are also XEPs that define addressing standards, security procedures. There is even an XEP that tells how to write XEPs. So most of XEPs introduce some new concept, and along with it goes a namespace. So you have like one-to-one mapping between features of XMPP protocol and namespaces. So if you want to ask an application, a server, for instance, what do you support? What can you do? You don't ask this question. You ask, what namespace do you know? And the server is going to send you back a list of namespaces, and then you know. It's as simple as this. And the XMPP is extensible, but when somebody asks me how to extend XMPP, the first question is don't. You most likely don't need to, because as I said, there's a lot of extensions. They are really carefully prepared and well thought through, very nicely designed. And there's like 98% chance that what you are thinking about is already there. Although I must say we had quite a few situations where we had to design custom extensions for a client. Usually these were custom implementation, which again had to integrate with some other features and therefore had some custom ways of communication. Okay, yeah, and now we're getting even more specific. Why the notion of namespaces and the fact that namespace very precisely define what we are dealing with helps developers to implement the support for this in a clean and orderly fashion. For example, in our Mongoose IAM, when you have IQs, the info query stanzas that are sent to the server, we have a notion of IQ handler, which is a module which knows how to handle a particular namespace. So when I send an IQ with some element inside qualified by namespace, I don't know, let's stick to privacy. Then there is a module mod privacy, and the main router directs the stanza, the IQ, to this module, because this is the registered handler for this namespace. And if I need to implement support for a custom namespace, I create a module which registers itself as a handler for this namespace, and I'm done. And there's a similar story with messages, because as I mentioned, the server scans a message looking for namespaces it knows. And it triggers some hooks. How it does it? It triggers some, for every incoming message, the server calls a hook for which any module can register a handler. So if I need to plug in some custom message processing logic, I can write a module which will register a hook handler, and then this module can do pretty much whatever I want, including dropping a message or sending back an error or pushing the message to some external microservice or whatever there is. So the point is that whenever a custom extension to the server logic is needed, it can be implemented in a couple of modules without touching the core code of the server at all, which is very nicely, which plays very nicely and lets us avoid many merge conflicts and other troubles of that sort. Okay, and what about integrations? This is a very important feature because in every installation, the chat, almost every installation, the chat server has to integrate with some other existing microservices. This is just one simple example because there are many approaches to integration. This is actually a real life, I think, from one of our projects, but of course I'm not going to give a name of the project. So here we have an application server written in Java, or I think it was Java, and the client application that communicates with the application server using JSON, and then a client registers, creates his own account, then he can do some socializing, networking, whatever there was. And this is also where his message archive is. But when he wants to chat, then he establishes a TCP connection to Mongoose IAM. Then Mongoose IAM needs to authenticate him. So Mongoose IAM will call applications, because authentication is also pluggable. So Mongoose will call application server to verify the user's credential. Now, if the guy has a group of friends, then the application server creates multi-user chat room in Mongoose IAM so that they can also they can share their stories on application server, but they can chat using Mongoose IAM in the same group. And whenever a message is sent via Mongoose IAM, it's pushed to the application server so that it's added to the message archive. And this is all possible because we have REST API, we have event pusher, we have pluggable authentication, and we have switchable backends. So, but this is just one of the options. You can also share database, you can put message broker somewhere, you name it. The limit is your imagination, provided the server you chose has the basic integration enabling feature. Quite a long sentence, I said. And we want it to integrate because it's not that we take an existing application and bolt a chat on top of it. It has to play nicely with everything else. And now I think we need Michał, because I was going to say that I will now leave the stage and to make room for my friend, but I'm not sure he's there.
I am. Hello.
Oh, hooray for that.
At least I am for now. There is quite heavy storm where I live, and this affects the mobile networks, and mobile networks are the only one I can use. So Bartek lost half of your presentation. Hopefully the storm will go away soon and I will not be disrupted by it too much.
Okay. Don't worry, I can repeat my presentation for you later on.
I hope if I'm disconnected, you can continue the part about scalability.
Okay, let's try.
You're also experienced with that. You've done a lot of load testing recently, so yeah, this topic is familiar for you. All right, let's get started with the scalability part. My name is Michał Piotrowski. I'm in the Mongoose IAM team almost, I think, actually from the very beginning when the Mongoose IAM project was started. So it's almost 8 years when I'm in the team. And I had a pleasure and a luck to work with many different installations of Mongoose IAM for our different customers. So I had a chance to see many different setups, and in all of them we had to think about scalability, how to reach certain level of users accessing the service and being able to chat with each other. And over these years, I learned that scalability depends on many variables. The most obvious one are the resources, the machine power on which the chat service runs. Typically, when you have a more powerful machine, lots of CPU or cores, lots of memory, the network is good, then you are able to fit more users on a single machine. But the scalability depends not only on the underlying machine, but also on the type of connected devices, the type of features which are enabled and used by the users, and also it depends on the database you use to store all the persistent data. Talking about different clients, devices, these days majority of the applications are mobile first or mobile only, and mobile applications have different pattern when compared to desktop applications or web clients. The biggest difference comes from the fact that the mobile devices can lose connectivity quite often, like it happened for me earlier today. And because of that, they will be reconnecting to the service more often. So they will put a slightly different load on the system than a web client, which is connected almost all the time and just sending messages using the established connection. Now, when we are talking about the features, the basic one-to-one conversations without any archiving is, of course, adding some additional load comparing to the system with only connected users. But the load is rather small. When we start adding additional features like group chats, then the load is even bigger on the system, because single message sent by one user in the group chat needs to be replicated and broadcasted to all the users connected and affiliated with the group chat. Then there is the presence information. If you have many friends on your roster, then your presence update needs to be broadcasted to all the friends. And if you send the presence updates frequently, this also increases the load, because these frequent presence updates needs to be broadcasted more frequently. And there is also message archiving, for instance, which basically writes the messages to some archive, and this puts additional load on the system, because the service has to contact some external database, write the message to the database, and when users are reading the messages, this also adds extra load when the message is read from the database. And in many cases, even if the machine is powerful, we have all the features enabled, and on the chat service side, we don't see much resources utilized. It may happen that the database is under heavy load and we have quite poor message delivery times, because the server has to wait too long for the message to be written to the database. So it is not only, the scalability doesn't depend only on the machine running the chat system, but also on scalability and performance of the other machines, the other nodes which are connected to the chat service. Now, when scaling the system, there are, of course, certain scalability limitations. The most three common ones are memory, CPU, and database, which I already talked about. The memory is strongly coupled with the number of users which can connect to the system. If we focus on users who are only connected to the service and doesn't exchange any messages, it is quite obvious that every new user session will consume more memory. Basically, we can assume that the memory grows linearly comparing to the number of users on the system. And at some point, we will not be able to add more users because we will run out of memory. But memory is not the only limitation which you can face. When the users are very chatty, exchanging lots of messages, then the CPU is being utilized more. And it may turn out that you will run out of CPU power before you run out of memory. And the third scalability limit is the database. So like I said, if the database doesn't respond on time, then we can observe that the end user experience may be suffering because of that. Now, when scaling chat service, in our case, that's usually Mongoose IM, we can have basically 3 steps. Usually we start small. When we experiment with the chat features, we probably want to know the server we are going to use. So we start with single node. But as soon as we are progressing with the development and closing to the production environment, it is recommended to start building a cluster of nodes. Because, in my opinion, this is what we recommend to our customers. The production environment needs to consist of a cluster of nodes, at least 3 nodes in such a cluster. So the sooner you start building and working with such a cluster, the sooner you will be familiar with how to operate and how to possibly debug certain issues with the cluster. Now, when you are on production, you have the cluster of nodes. You can, of course, add more and more nodes to the cluster, but this doesn't scale infinitely. There is some limitations of the number of nodes in the cluster. But if we have powerful enough machines, we can handle millions of users on a single cluster. But single cluster is not always the end solution for some of our customers. Sometimes they want to reduce the latency as much as possible, so they want to build many clusters and deploy them where the majority of users are placed. So if we have a customer which aims for global community, then most probably there will be at least 3 different clusters in 3 different continents: Europe, USA, Americas, and Asia. And now I'm going to briefly describe all these 3 steps, and we will go through the single node to multiple cluster installations. These steps probably apply to other solutions, not only Mongoose IM, but since we are building Mongoose IM, this is written in Erlang. I will give some examples why Erlang and Mongoose IM shines when scaling the chat service. So first of all, the single node. Thanks to the Erlang virtual machine and the Erlang language, we can basically utilize all of the available CPUs on the machine. Erlang was designed with concurrency in mind. So from the very beginnings of Erlang existence, there was the idea of processes, very lightweight processes, which you can spawn hundreds of thousands or even millions on single Erlang virtual machine. And thanks to the schedulers, all the lightweight processes can be executed on all the available cores. Erlang processes are isolated, so if one crashes, it doesn't usually affect the other one, unless they are linked, but that's out of the scope of this meeting. But we can assume that one user, which in MongoDB case is represented by 2 or 3 Erlang processes in the system. If for some reason the processes for the single user crash, other users are not affected and they can still happily use the service. And with the single node, thanks to the Erlang concurrency model, we can scale the single node instance by adding more and more resources. And single node installations have some advantages and disadvantages, of course. They are good for development, where you have only single node which you can connect to and diagnose some issues, see what, for example, the client application is sending. They may be enough for very small installations where you don't care that much about the fault tolerance and availability of your service. But as soon as the availability is important for your product, then single node installations are single point of failure. And from here, we go to the cluster installation. And the cluster of MongoDB nodes can be described on this diagram. So basically here we have 3 MongoDB nodes connected into a cluster, and to each of the nodes there are client connections opened, and thanks to the clustering and Erlang distribution, which forms the cluster, users connected to node 1 can send messages to users who are connected to every other node. MongoDB clustering relies heavily on the Erlang distribution layer and the Mnisia database, which helps us to establish the cluster and then maintain the connection, so that if the node joins the cluster once, it doesn't have to join it again after restart. Thanks to Mnisia schema, we will have the automatic rejoin to the cluster after a restart. And also, thanks to Mnisia tables, we can easily replicate data between all the nodes in the cluster. When talking about Mnisia tables and replication, we are talking only about the RAM-only copies. Of course, MongoDB supports disk copies for many of the extensions which need to store persistent data, but for production installations, we strongly recommend to configure MongoDB to store all the persistent data in external database like MySQL, Postgres, React, or Cassandra. But when it comes to session information, we typically store it in Mnisia, and this is enough for majority of the installations. Now, when adding more and more nodes to the cluster, we are connecting more and more connections between all the nodes in the cluster. Erlang distribution works in a way that if new node joins a cluster, it is immediately connected with all the other nodes in the cluster. So basically, we have a full mesh of connections between all the nodes in the cluster. And at some point, the communication overhead becomes too much, too big, and there is no point in adding more nodes to the cluster. If at this moment we still need to scale the solution, we can, for example, exchange some of the nodes in the cluster with more powerful machines so that we increase the capacity of the entire system. But also we can start thinking about moving into multiple cluster installations. And in this case, we basically deploy many Mongoose clusters, and you may wonder how they can connect and talk to each other if there is no Erlang distribution between these clusters. And here comes the XMPP and the XMPP Federation, which is part of the core protocol. XMPP Federation works similarly like email. You can send emails to users who have their accounts on different domain, and the same is with XMPP Federation. For instance, we can have two different clusters hosting two different XMPP domains. One, for example, is eudomain.com, and when users on that domain send a message which is addressed to users in domain us.domain.com, then the server will try to establish the connection with the cluster serving the other domain, and the message will be delivered using the XMPP Federation mechanism. The mechanism is so generic that, for instance, you can have cluster of Mongoose IAM nodes in one of your data centers and cluster of another XMPP server nodes, for example, Tgaze or OpenFire, in different data center, and they can happily talk to each other with the XMPP Federation. Now, when scaling and observing the system on production, it is really important to set up monitoring and basically push the metrics which Mongoose stores inside to the metric database. And Mongoose metrics, they show you the user behavior, how users are using the system, how many messages they are sending per minute, how many presence stanzas are exchanged, what extensions are used by the users. But also these metrics can show you the latency when talking to external services like databases or maybe push notification service. Inside Mongoose IAM, there is hundreds of different metrics which helps you to understand how the system behaves, what are the usage patterns. And using these metrics, you can start thinking about creating some load testing scenario, because load testing, in my opinion, is also very important when preparing for production deployment. At the very beginning, you may not be aware, or you don't really know what is the usage pattern of your users in the system. But even without that, it is important to start load testing with some scenario which you think may be reflecting the real traffic. It is important to load test basically in order to measure the capacity of your current system, current cluster, and also to learn how the system behaves under not very big but stable load. And when load testing Mongoose IAM, we recently use our own tools. This is Amok and Amok Arsenal XMPP. All right, that's all regarding scalability. And the last topic for today are push notifications. Like I already mentioned, majority of the chat applications recently are focused on mobile devices, and with mobile devices, we need to have push notifications. Fortunately, XMPP provides a XEP for that. It consists of two parts. One is out of XMPP scope and basically requires you to get some token or identifier from the push notification provider. And the other part of the XEP shows you how to enable the push notifications on the client side, and also how to deliver the push notifications on the server side. The XEP for push notifications is very generic. It is based on PubSub. It was done this way in order to provide certain flexibility so that the PubSub nodes delivering push notifications could be separated from the nodes which serve the user service. Basically, we can see it on a diagram here. As you can see on this diagram, when the client application needs to enable push notification, it first of all has to obtain the token or some identifier from the push notification service. In our case, this is APNS or FCM. When we have the token, then we need to allocate the PubSub node. And on this diagram, you can see that the PubSub service is running on a different node. Here it is Mongoose IAM, but thanks to the XEP, it doesn't have to be Mongoose IAM. It can be some other XMPP aware service which understands the PubSub protocol and can allow us to create the node. When the application created the node, it then enables the push notification with the name of the PubSub node and the token obtained from the push notification service. And now, when the push notification is enabled and there is a message addressed to the user which is offline at the moment of sending the message, then Mongoose will look for the PubSub node responsible for delivering push notifications, and it will publish push notification data to the PubSub node, which in turn will contact the push notification service directly or via some additional service. In our case, we usually deploy Mongoose IAM with Mongoose Push, that's external component, which talks to APNS and FCM. One more thing regarding the push notifications. In case both the PubSub node and the node delivering the service to end users are on the same server, there is actually no need for the PubSub service. And recently we made some optimizations to the whole push notifications feature so that you can configure Mongoose IAM to talk directly to Mongoose Push without the need for creating and sending the PubSub messages. And this reduces the latency quite significantly and also reduces the load on the entire system. And when it comes to Mongoose Push, this is service written by us in Elixir. It is stateless. There is no need to cluster it. If you need to scale, you basically add more stateless nodes of Mongoose Push. They expose REST API, which is common for both APNS and FCM. So on one hand, you have the same interface to send push notifications to both providers. And on the other hand, Mongoose Push will send the push notification which is formatted correctly for the specific push notification provider. And also it is built with ease of observability in mind. There are structured logs, and there are metrics which you can use to observe if the push notifications are delivered correctly or not. And that's it, what we had prepared for you today. Hopefully, fortunately, the storm went away, so I was not disrupted.
Thank you so much, both Bartek and Mikhail. We've got time for a couple questions. So if you have a question for our Mongoose IM team, please let us know on Twitter at either Mongoose IM or at Erlang Solutions, or alternatively in the questions part of GoToWebinar. The first question we've got that we'll start off with is, how, as a chat application owner, do you decide which features to build or pay more attention to?
Bartek, do you want?
Yeah, could you repeat the question? I'm not sure I got it.
As the owner of a chat application, what informs your decision on what features to introduce or spend more time developing?
Oh, it's a big question, and it's actually the most difficult part of the whole job for us as consultants, for example.
Yeah, Bartek, you said you spent 3 weeks defining that in Bangalore.
Yes, exactly, because it all boils down to this: what the application is supposed to, what service the application is going to provide to the end user. And this is very, very dependent on the whole idea, the whole concept of the application. So normally we have to start often. It depends. Sometimes because we are not. Most cases we are not the application owner. So we just work for the application owner, and either sometimes he knows exactly what's important and what are we going to deal with. And so in other cases, we have to take off the developer's hat and put on the consultant's hat, and spend a lot of time talking, designing, discussing ideas, and figuring out what features are to be provided. And then the outcome of this discussion of writing down specification is that then we have to map them. The expected features, the requested features, we have to map them to XEPs, either to existing XEPs, to extensions that exist in the XMPP protocol, or if there is nothing, no direct support for this in XMPP, then we have to design our own one, our own. But this is a really challenging, and it's actually I won't say it is the fun part, but it's fun. It's really interesting challenge. Does this answer the question?
Yeah, perfectly. Thank you. Another question we got through is, can you support end-to-end encryption?
Yes, that is possible. The end-to-end encryption is most of all a client feature. There is XEP, at least several XEPs for that. But as far as I know, the most popular one recently is called Omimo. And in case of this XEP, what the server needs to provide is only the PubSub service to distribute the keys, the public keys to decrypt message. And the rest of the encryption, end-to-end encryption, is done on the client side. And the server has no idea what is inside the encrypted message, and the server has no way to decrypt it.
Perfect. And then the last question that I can see that we've got on this one come through during this is, does Mongoose IM support VoIP?
Yeah, that is very often asked questions. Mongoose IM by itself doesn't provide VoIP, but Mongoose IAM can be used to establish and negotiate the VoIP session parameters. There are steps around that. The extension is called Jingle, and using the XMPP protocol and Mongoose IAM, you can negotiate the session, but then when the session is negotiated, the traffic goes peer-to-peer from one user to another. In the perfect scenario, you can establish the direct connection between these two devices. If that's not possible, you will need some relay server. And there is Mongoose ICE component, which you could use to add VoIP feature to your application. But like I said, Mongoose IAM will be used here only to negotiate the connection parameters, and that's it. The real traffic, the audio and video will go through out of Mongoose IAM.
Perfect.
Because audio and video connections are normally peer-to-peer, so there's no straight server support for it because server is not part of the connection. Server is only supporting establishment of the connection.
Perfect. Thank you so much, Bartek and Mikhail. I think I speak for everyone when I say this was a super helpful webinar. Thank you everyone who's joined us. As always, we will send out a recording of this webinar with some of the relevant information that we've discussed today to your email by this time next week. So look out for it in your inbox. Thanks and take care.
Thank you. Have a good evening or afternoon, whatever part of day left for you.
Yeah.